Namaskar. Welcome in this lecture series on software engineering fundamentals. This is Dr. Bright Keswani, professor in computer science, Suresh Gyan, Vihar University. Today we will discuss about the software reuse and activities. These are the learning objectives and learning outcomes. Through this lecture, you will learn all insights about software reuse and related activities in detail. As far as learning outcomes are concerned, after the completion of this lecture, you will be able to understand the importance of software reuse and how to make software reusable. These are some topics to be discussed during the lecture. First of all, we will give you the overview of software reuse. Then we will discuss about the importance of software reuse, and there are various types of software reuse, so we will discuss about them. Then motivation for software reuse will be discussed. Reuse engineering and information engineering will be discussed. Assets for software reuse, it is a very important topic, and we will discuss during this lecture. We will discuss about various levels of software reuse and planning for software reuse. There are several software reuse activities, so we will discuss all the activities and briefly. Then we will discuss about various steps for software reuse implementation. We will discuss about software reuse matrices and potential benefits of software reuse. And at the end of this lecture, we will discuss about various factors influencing software reuse. So let us start with the overview of software reuse. You can say that software reuse is the process of implementing or updating software systems using existing software assets and the systematic development of reusable components. The systematic reuse of these components as building blocks to create a new system. System software reuse can also be defined as the systematic process of developing software from a stack of building blocks. So that similarly in requirements and architecture between applications can be exploited to achieve substantial benefits in productivity and business performance. So in a nutshell, you can say the reuse is the process of creating software systems from existing software systems rather than building software systems from the scratch. Software reuse has also been defined more fully as the systematic process of developing software from a stock of building blocks, so that similarities in requirements and architecture between applications can be exploited to achieve substantial benefits in productivity, quality, and business performance. So, software reuse is the important concept of software engineering. Let us discuss about the importance of software reuse. So, the software crisis is detected in 1960s when there are no reusability concepts in existence. Uh, so, software engineering came in existence with the idea of reusability. Means do not uh, once you develop a software project, once you develop a component which is effectively workable component, and it is effectively produce the desired results, and which is the error free algo or the model of the system, then there is no need to develop it again for the new project. So this concept named reusability came in existence. We there is a need uh, uh, to develop software in a way that it should be reused with other softwares. Okay, so modular programming, adoption of modular programming or component based programming or component based designing is the solution, and it is the method, you can say, make the software reusable, which is the essential and important quality parameter. As far as portability is concerned, it is to moderate the effort needed to funding applications across way assorted uh, OS platforms and programming languages and compilers. As far as flexibility is concerned, to wherewithal growing series. To attain enhanced software more rapidly and at lesser cost, we need to assume a design process that is built on methodological software reuse. Reduce budget, time, effort, and hazard. We can reduce the budget, we can reduce the time, average time of the development, we can reduce the efforts, and we can reduce the errors and hazard when we are using the we are making the software reusable. We can increase productivity, we can increase quality, we can make the software more presentable, and we can achieve the interoperability also when we make the software in a way that we can reuse it. So they, there are some important thing which is when we are talking about reusability, or we can say these things are related closely, associated closely related with the software reusability. So there are several importance of software reusability, and it is suggested by the software engineering that you should make, being a developer, you should always make your or design your software system as per the as per the software engineering recommendations, and consider the reusability as a important issue when you design a system. These are the various types of software reuse. There are three types of basically software reuse: vertical or domain reuse, then horizontal or general reuse, then product line reuse. Vertical reuse occurs when a component is specific to an application domain. For example, assets that capture the business knowledge, such as the design and code for a customer management model or financial object model. These can be reused in other applications within the same domain. And this type of reuse will not work within all domains. For example, it will be difficult to achieve successful reuse for domains which have time and space constraints. So companies have attempted to turn domain-specific reuse into a marketable opportunity by carrying out domain analysis and development components to sale, but not many have succeed. So most successful programs are internal. The reuse of horizontal assets, sometimes called general reuse, and the general reuse or horizontal reuse to software components used across a wide variety of applications, and it is type of reuse in which can be reused within other application domains also. So we can say it as a general reuse, because it is we can be reused within other application domains. For example, user interfaces or database connection libraries and component tend to be abstract data types with common behavior throughout different domains. So what is important? Vertical domain reuse important, which is specifically used specific domain. And general reuse means what? It in this type of reuse you can reuse the component in every each and every domain, or other than particular application domain. Okay. Then the last one is product line reuse. A product line reuse is a set of software intensive systems sharing a common managed set of features that satisfy a specific need of a particular market or mission, and that are developed from a common set of core assets in a prescribed way. So these are three types of software reuse. Let us discuss about the motivations for software reuse. So today's organizations face competitive pressures in shortening the time required to bring software product to the market and reducing software development and maintenance costs, also increasing the quality of their product or software product. Organizations have increasingly uh, turned to a reuse strategy in order to meet these business goals. So, to success in a business, what is needed? It is needed to develop a reduce cost software. It is required to increase the quality of the software, and it is also needed to develop a software before the given time limit. So, motivation, what are the motivations for software reuse? There are several goals of software reuse. Uh, as enlisted here in this slide, it increases productivity, reduce risk, shorten time to market, it improves software quality, it improves functionality and performance, it provides consistency and interoperability across product, it ensures product conformance with user requirements through prototyping, and leverage technical skills and knowledge. When we talk about increased productivity, so after an initial investment, reuse of existing assets will enable projects to decrease the cost of developing and maintaining softwares. When we talk about reduced risk, the risk is creating new software is reduced when available reusable components already encompass the desired functionality and have standard interfaces to facilitate integration. So when the components are already duly checked in the uh, previous project, and we are using the same component with our new project, then it have because of the uh, testing conducted in the previous project, the tested modules will provide the more security and having reduced risk. Okay. The next is shorten time to market. Software reuse reduces the time to market, and software that has been used multiple times will process fewer defects than freshly coded component. So it improves the software quality also. It improves the functionality and performance also. A reuse allows for the investment of time to improve functionality and performance, because this time can be uh, utilize over multiple uses of the asset, and this investment for such improvements in more is more economically justified than the case where they would only be for single product. uh, the software reuse provides consistency and interoperability across products also. Standard interfaces and common use of components across product facilitates ease of use and interoperability. So these are some uh, interoperability implemented appropriately. Reuse can add in achieving some or all of the goals and listed in the slide. Let us discuss about the reuse engineering and information engineering. Engineers will often work with a team to help them to configure an asset for a specific use. The goal is to make it as easy as possible for others to reuse existing assets, thereby increasing the chance of rate of successful reuse within your organization. Integrate reusable assets into a solution. Information engineering is the engineering discipline that deals with the uh, generation, distribution, analysis, and use of information, data, and knowledge in the system. The field first became identifiable in the early 21st century. So you can say that reuse engineering is an extension of information engineering that incorporates reuse considerations, techniques, guidelines, and matrices into a class information engineering paradigm. Information engineering is a good base for use for several reasons. Like, information engineering is currently widely known and widely used for developing business applications and is supported by many powerful automated tools. Information engineering supports system view through its enterprise modeling that is also needed for reuse. Okay, so information engineering and enterprise models can be analyzed to identify common, highly reusable components that can be built prior to system development and then used to build the new systems that one of the most priority of the business. Okay, so let us discuss about the next topic is assets for software reuse. Assets reuse is the component, uh, any component that is specifically developed to be used and is actually used in more than one context. And this does not just include code. Other products from the system lifecycle can also be reused, such as specifications and designs, and even requirements on occasion. Components in this case can be taken to include all potentiality, all reusable product of the system lifecycle, including code, documentation, design, and requirements. So there are various criteria that should be satisfied in order uh, for an asset to be successfully reusable. There are these are grouped into general requirements, functional requirements, and technical requirements. General requirements focuses on aspects such as compliance with relevant standards, completeness, modularity, and simplicity. And functional requirements includes such concerns as which business processes it will simulate or automate, and how well it does this. Functional requirements mainly concern vertical or domain specific assets and tend to be very specific to each information domain. When we talk about technical requirements refers to the criteria such as interoperability, portability, communication, security, etc. So there are different levels of reuse that can be considered. First, at the highest level, entire applications can be reused on different platforms provided they are portable, and subsystems can be reused within different applications, probably within different domains also. At a lower level, modules or objects can be reused, and at the very lowest level, single functions can be reused. And this is also known as classification of the granularity of components. Okay. Reusable assets can be built in-house, retrieved from legacy or old systems, or can be brought from an external resources. And many components are available free of charge from universities or non-profit making organizations, as it is very difficult to make a profit selling generic component. So let us discuss about levels or strategies of software reuse. There are several strategies of software reuse like ad hoc reuse, systematic reuse, domain oriented reuse, and strategy driven reuse. When we talk about ad hoc reuse, at this level, engineers tend to reuse their own libraries and code fragments when they notice a similarity between the projects. And in the systematic reuse, this type of reuse is driven by a well-ordered process and coordinated planning. Resources are allocated specifically for a reused diagram, and it is fully supported by the management. When we talk about domain-oriented reuse, and at this level, the organization focuses on creating a library of reusable assets within the existing and future business domains. And this allows the organization to build up a repository of reusable components and therefore to be more competitive. Okay, when we talk about strategy driven reuse, this is the highest level of a reuse. Reuse helps to define the development of new products and processes. Reuse is accepted as part of the process of development and should be longer required target of incentives. When we talk about software reuse activities, there are two main reuse activities. First is development for reuse, second is development with reuse. The difference between the two activities is that development for reuse is when new components are designed in order to be reused, and development with reuse is when existing components are made use of within a new system. So there are these are the two main activities, reuse activities suggested by software engineering. These are some steps for software reuse implementation. A successful program in reuse starts with the recognition of reuse potential. A stable, mature, and well understood domain offers the best possibilities for reuse. These are the steps necessary to implement software reuse, and all steps are listed here. Let us discuss the first step, that is access organizational readiness. Understanding the people, process, product, technology, asset, economic metrics, and management facets of the organization, and how reuse will impact each of these aspects are the key features, key issues of uh, assess organizational readiness step. In the second step, you should identify a set of product product efforts that may be a good candidates for reuse. In the third step, that is identify and collect matrices. While this activity is done throughout, the reuse efforts are necessary. Collecting matrices early will enable us to benchmark the organization and how the impact when reuse is implemented. Matrices are defined based on those business goals reuse is assisting the organization in reaching. When we talk about the next step, that is identify domains in the organization, it enumerate a, a list of domains that are in common within the organization. These may include horizontal domains like graphical user interfaces, error handling, and vertical domains also like manufacturing applications. Okay, let us discuss about the next step, that is collect an inventory of existing material. In this step, we locate candidate components for each identified domain. In the next step, uh, an informal domain analysis may be conducted for the chosen domain. And then and next step, consider establishing an independent producer group, and this would dedicate resources to ensure that the necessary assets are created, managed, and supported. In the next step, that is create and managing reusable assets. In this step, make, buy, or re-engineer existing assets for users. Bring these assets under a source control and configuration management system. When we talk about establish a new process for producing, managing, and using a reusable asset, after obtaining a clear understanding of the current processes for software product development, determine a process for producing, managing, and using reusable assets that addresses the particular need of the organization. The next three steps are also important steps. Utilize tool technologies and standards and conduct reviews and walkthrough to reinforcement of reuse, because you can review can provide you walkthrough can provide you the uh, faults and failures in the implementation. So this is necessary step. Then pursue continuous process improvement. It is again a very important step, continuously monitoring and pursue incremental improvement to the reuse program, explicitly uh, feedback from the user and other participants in the reuse efforts. So these all are the steps for software reuse implementation. Let us discuss about the software reuse matrices. Software reuse matrices are an essential part of reuse engineering. and they help determine the extent to which reuse should be practiced in system development projects and what components should be created and stored for future reuse in the software reuse library. The general reuse matrices of a reuse engineering are commonality of component, reuse threshold of a component, reuse merit of a component, reuse creation cost of a component, degree of a reusability of a system, and reuse merit of a system. Let us discuss all of them one by one. When we talk about the commonality of a component, it is used to measure how frequently a component reoccurs across a set or family of systems. When we talk about reuse threshold of a component, it is used to indicate the minimum number of times a reusable component must be reused to pay back the investment in creating or preparing it for reuse. When we talk about reuse merit of a component, it is used to measure the reusability of a component relative to the average reusability of a component of the same type. When we talk about reuse certain reuse creation cost of a component, uh, it is used to measure the cost of creating or preparing a component for reuse, and this includes the uh, uh, cost of purchasing the component, identifying it via domain analysis, and preparing it for reuse. We will discuss about generalization, standardization, certification, classification, and documentation in this matrices. Then reuse uses cost of a component is another type of matrices, and it is used to measure the reuse related cost incurred each time the component is reused. And this includes the cost of finding, understanding, modifying, and integrating the reusable components. When we talk about the reuse maintenance cost of a component, it is used to measure the cost of supporting a reusable component. Uh, when we talk about the reusability of a system, it is needed to measure the uh, proportion of a system's component that are reusable. And lastly, uh, we will discuss about the reuse merit of a system. It is used to measure the proportion of a system that is reusable relative to the average proportion of for a system in one business area, domain, or across the entire corporation. So these are some software reuse matrices. A list is provided here. Let us discuss about the potential benefits of software reuse. There are several potential benefits to an organization of implementing a successful reuse process. The main technical benefit are improved productivity, improved software quality, and business benefits. When we talk about improved productivity, the first main aim of software reuse is to improve the productivity of the developers. This is achieved because of the reduced development time due to the fact that the components have already been built. And in order for a component to be suitable for reuse, it must have appropriate documentation and must be tested thoroughly, and ideally should have uh, should also have been certified to confirm their quality. So remember, productivity is increased and the development time reduced, which helps with the ever decreasing time to market or lead time factor, which is becoming the most important factor in the highly competitive and rapidly changing technology market. When we talk about improved software quality, the quality of the software produced in increased is increased by the introduction of a reuse program, because the component used will have already been tested in live programs and in a variety of situations if they have been used in other projects, and therefore any problems should have been rectified already. The reuse of components also improves the reliability of the system for the same reason. The reused components are tested in a variety of realistic operating conditions and therefore should be more reliable. So, what is uh, how reusable or reusability issue or reusability factor affect the quality of uh, software? The business related benefit, when we talk about business related benefits, the organization will benefit both economically and otherwise from a reuse program. The improvements in productivity will lead to quicker production of products and components, and also to higher profits or cheaper products, and this will give them a shorter time to market, which will improve the competitiveness of the organization within its own domain. So there are mainly three factors. You can say the three technical benefits we had discussed here, that it will improve the productivity, improve software quality, and business benefits. The improvement in product quality will lead to better service for the customers and ultimately a better image for the business. Otherwise, less obvious benefits includes the chance of both direct and indirect new business opportunities, as the component themselves can be sold or new market can be identified. Economic benefits will include saving money on the development of new products, saving money on the productivity of the development team, and reducing the time to market of a new product. So, there are several potential benefits of software reuse. Let us discuss about factor influencing the software reuse. The major factors that influence software reuse includes cost, legal, managerial, social, and cultural issues. All the factors we will discuss one by one. The cost, as far as the cost is concerned, three types of cost are associated with reuse. First is the cost of building the reusable component. Secondly, cost of a reuse, and thirdly, cost of the reuse process. When we talk about legal factor, then contractually on certain projects, the developed artifacts are the property of the contracting organization. Hence, any reuse is a violation of their ownership of an item. When we talk about managerial uh, factor, management can find it difficult to reconcile the issue of reuse in determining a developer's productivity. And this relates both to the developer producing a reusable component as well as the developer incorporating an existing component into a product. In the first case, charging the development cost of a reusable component to a certain project may not be justified. And in the second case, there is difficulty in counting the developer's SLOC based on reuse. As far as social factor is concerned, some developers actually believe increased reuse implies reduced employment. So, this is the social related factor. And last factor is cultural factor. Designing a reusable component does not in itself ensure reuse. To be reused, the individual item must be identified by another developer as a candidate for other application. The implies an infrastructure where components are described and that description is accessible easily. So these are some factors influencing the software reuse. Let us, this is all from my side. Let us discuss some questions, objective type questions. The first question is reuse based software engineering is a software engineering strategy where the development process is generated to reusing existing software. State this is true or false. The answer is true. A. The open source movement has meant that there is a huge reusable code base available at free of cost, available at low cost or high cost or short period of time. So the right answer is low cost. B. Consider the example and categorize it accordingly. A sentence is given here. A pattern matching system developed as part of the text processing text processing system may be reused in a database management system. The four options are application system reuse, component reuse, object and functional reuse, and none of the above. The right answer is B, component reuse. Let us discuss the next question. Quotes stand for commercial off-the-shelf system, commercial off-the-shelf states, commercial off-the-system state, or none of the mentioned. Answer is commercial off-the-shelf systems. Courts product reuse means what? Four options are classes and function libraries that implement commonly used abstractions are available for reuse. And in the second, shared components are woven into an application at different places when the program is compiled. And the third option is large scale systems that encapsulate generic uh, business functionality and rules are configured for an organization. And last option is systems are developed by configuring and integrating latest application development. So these are four options and the right answer is D. Systems are developed by configuring and integrating existing application systems. Let us discuss about the next question. .NET are specific to which platform? Java, Mac OS, Microsoft, or Linux. It is uh, .NET is specific to the Microsoft platform. Let us discuss the next question. Which of the following is a general structure that is extended to create more specific subsystems or applications? Software reuse, object-oriented programming language, framework, or none of the above? The answer is framework. An ordering system may be adopted to cope with a centralized ordering process in one company and a distributed process in another. Which category the example belongs to? Four options are process specialization, platform specialization, environmental specialization, or functional specialization. The right answer is process specialization, that is A. What are generic applications systems that may be designed to support a particular business type, activity, or sometimes a complete enterprise? The um, probable answer are codes solution system, codes integrated system, ERP system, or both code solutions and codes and large and uh, integrated systems. So the right answer is A. And the last question, which of the following is not an advantage of software reuse? The options are lower cost, faster software development, high effectiveness, or lower risk. So the answer of the of this question is high effectiveness. That is C. So that's all from my side. These are some reference book. If you have still have any query about the contents which I delivered, then you can consult to these books. You can refer these books to solve your query. Thank you. Thank you very much.